So welcome everyone for today's webinar. We've got Unlocking the Power of Geothermal with Heat Pump Solutions from WaterFurnace with Will Lane. He has done one for us in the past. I really appreciate him being here. As always, today's webinar is being recorded. It will be uploaded to our YouTube channel, which you can find by searching Spear on YouTube, or you can go directly to our website at eepartnership.org, and under the news section, you'll find our resources page. Once you're on the resources page, you'll find a link to our channel. That takes you directly to our channel that has over 150 videos that have been uploaded with a variety of topics that are there, even from the CELC that Sean does for us as well. Today's webinar is eligible for ICC CEU credits. However, this is kind of an update to one that Will did for us in the past. So it has the same CEU number that's on it. So if you go to turn that in and it shows that you already have that you've already claimed that, then you may not be able to get credit for that as a new. So apologize for that, but that's kind of how this one's going to work for us. As always, this will be uploaded in about 72 hours. You'll receive a course evaluation email from Kathy Lawrence. Please complete the survey, send it back to her to receive your course completion certificate. So as I just said, if you haven't already claimed this, then you can use the title and the course ID to claim it when you're reporting your ICC CEUs. As always, I will have the chat feature open. Please report any technical difficulties that you're experiencing during the presentation. Also, the Q&A will be open. You can use either the chat or the Q&A to put questions during the presentation. And then if we can, we'll jump right in and kind of put a pause and ask the question during the presentation if the question is about something that's on the screen. So anybody that's here new with Spear, who Spear is and what we do. So we provide training in webinars, in-person, field training, as well as I can do a one-on-one or a group IECC test prep training for anybody looking to get certified. We don't charge for that. It's just something I help do to keep myself fresh on going through the codes. I can help with questions regarding energy code, ASHRAE 90.1. I can help questions from plan reviewers, building officials, third parties. I really appreciate people calling and reaching out to us. As you know, right now with the government pause in some of the nonprofits that are out there, some of their technical resources or technical assistance is no longer replying to emails or picking up on the phones. So I'm happy to help and assist any way that I can. We still assist several cities with the adoption of 21 and now looking to adopt 2024, help navigate some of those amendments that other cities are doing to lessen the impact of the adoption for the building community. As always, my information will be at the end of this presentation. Please feel free to reach out with me on any questions. Love to help you navigate through the energy code. And also, Will probably give his information at the end as well. You can reach out to him with questions specific to their solutions and things that they have for product. So, Will, I will let you introduce yourself, and then I will stop sharing, and you are in control.
Well, thanks. I'm going to turn off my video and give you guys a little more bandwidth so we don't jerk around much. In any case, a couple of housekeeping items. Apologies to our Oklahoma folks that are here. This is the information that I'm presenting is applicable to both Texas and Oklahoma, but as a longtime resident of Texas, I just sort of fell into the Texas thing. Another housekeeping item is you'll see my corporate logo down there in the lower right. I want to emphasize this is not a sales pitch. I'm not trying to sell anybody a heat pump. I'm trying to emphasize the importance of the technology, that it's a valid solution for the southwestern part of the United States. In fact, one of the largest manufacturers in the industry is headquartered right in Oklahoma and a competitor of mine. So I want to keep this balanced. Almost everything I tell you today will apply to geothermal in general, but just some good information. I've got about 50 pictures here I'll show you, and we'll open it up for Q&A. We got lots of time. I'm going to finish up a little early and give you some of your Tuesday back. Let's see what we got. We'll start with some first principles, and this may be ridiculous to some of you, but I promise you that when we do this live on stage, it's a lot of fun. We get two guys with big screwdrivers and we heat them up red hot. And we say, okay, you guys are in a competition. One of you gets a bucket of air. One of you gets a bucket of water. The first one to grab the hot end of that screwdriver wins the race. And so we get them red hot. The guy with a bucket of air sticks it in there and waves it around. The guy with a bucket of water sticks it in there, swirls it a little bit, and grabs the screwdriver. And the poor guy with the air-cooled screwdriver is left standing there for quite a while, hoping it cools off because he's not going to grab it. The point of that is that water conducts heat extremely well. And when we're talking about ground source heat pumps or geothermal heat pumps or water source heat pumps, we are using water as our heat transfer medium instead of air, and it works really well. I'll show you how well here in a couple of slides, but that's a fun demonstration and a great way to explain kind of a first principle of geothermal and heat transfer. So here's a second first principle. It's hot in Texas. I know it. I had no air conditioner for a week once when it was 105 degrees, and that's tough. But I will say that even when the air is that hot in Texas, the groundwater temperature hovers around 67 degrees, maybe as high as 72. But that's 30 feet below the surface. And that temperature remains that all year round, regardless of seasonal variations or climate variations over the short term. That's 72 degrees, 70 degrees, whatever, all the time. It's non-seasonal, and that is your heat transfer source for ground source heat pumps in Texas. If you saw this last year, you saw this slide as well. This is one of my favorites. This was Winter Storm Uri just a few short years ago. But even during that storm, the temperature 30 feet under Texas was still 62 to 72 degrees, steady. So that's, once again, the place where we get our heat in the summertime. And interestingly, if you have a ground source heat pump, that's where you put your heat in the summertime, and you can pull it back out sort of in a localized way in the wintertime. So you're using the ground both as a source of condensing and evaporating your coolant, but your refrigerant, but also as a thermal battery. And we're going to talk a little bit about that later. So geothermal is renewable. Step into our third sort of first principle. For every unit of electricity, maybe a kilowatt hour that you put into a ground source heat pump, it's reasonable to expect in a typical ground source installation to get 5 units of heating or cooling delivered from that machine. I know that sounds like magic. It sounds crazy. It's incredible. It takes a while to figure it out. But if you just think of a ground source heat pump as a pump, it makes perfect sense. You're pumping heat out of a building and into the ground, or pumping heat out of the ground into a building. Just like a water pump. You get a whole lot more water out of a water pump than the electricity that you put in. So a heat pump is really just a pump, and you're moving heat from one place to another. And that's how you can get 5 for 1. For bonus points, what is the COP of that equation right there? You get 1 unit from the grid, 4 units from the ground. That's a COP of 5. So geo is renewable. It's the law. It's in the code of federal regulations, and it is recognized as renewable energy, which is one reason why you get a 30% investment tax credit in both commercial and residential geothermal today. So let's talk about Texas. And for those of you in Oklahoma, this information applies as well, except for you folks in Oklahoma City where you put in your air handlers upside down. Well, this still applies. But I would guess that none of these homes have geothermal. I would suggest that all of them could. How would you do that? Well, you got a lot of different choices here. That happens to be my company's product line. Other companies have similar product lines. Those are packaged units in the middle. That's a split outdoor unit on the right. And on the left, you've got a split indoor unit and a hydronic unit. Just for scale, that's about the size. The units in the middle are maybe a 5-ton furnace with a coil on top, a short coil. And on the left, that's about half the size of a 5-ton furnace. A little shorty here, just for scale. So you've got packaged, you've got verticals, horizontals, you've got splits, you've got hydronics, even ductless console units that can or cannot have outside air, and wall-mounted hydronic units that other manufacturers can provide, third-party coil-type manufacturers. Lots of choices. So if you're thinking mini splits, if you're thinking PTACs, consoles, packaged units, split systems with air handlers or furnaces, all those solutions are available for you in Texas and Oklahoma. Here's what a closet installation might look like. A typical ground source heat pump, geothermal heat pump, would have a side return. Here you see right side return and a top supply. You can see the water lines coming in on the lower right and the electricity coming in on the lower right. You can see the flow center up on the left next to a zoning panel. All kinds of options. That would be a typical closet anywhere in the country, even on a slab mounted home. Inside these units, it's a lot of stuff in a small box. Basically, on the top half, you've got an air handler with a coil on the right and a fan there on the top with the exhaust. You can see that's a variable speed blower. Down below, you can see the control on the left. That panel can swing out so that on the right, you can actually see your compressor and access all those components. You can tell by the heat sink and the vents on the lower part of the package that has a variable speed drive on it and a variable speed compressor. Also, you can see, if you're familiar with fan motors, that's a variable speed blower fan as well. Here's a garage installation. Typically, most of these systems are installed with a water storage tank because they have what's called a de-superheater, and those are those two lines up here on the right, the upper two black lines. They're feeding that water tank with a de-superheater, only meaning that they're taking the heat from the operation of the compressor and making 120-degree water. Typically enough hot water for 2 people, shower, wash dishes, and do their laundry. Not enough for a 4-person family, especially if they have teenagers. But de-superheaters are common on these systems and are typically installed with a tank. And that could be either a storage tank or an electric water heater combination. Here you go with a closet installation of an indoor split unit. You can see the refrigerant lines in the upper right-hand corner going out to an air handler or a coil sitting on top of a furnace. And this is a outdoor split, the exact same product, just in a weatherized container. You could actually, in Texas or Oklahoma, replace your outdoor condensing unit with that geothermal split unit and reuse the same pad, the same whip, the same disconnect, and the same line set to your existing system in your attic or your crawl space or your closet, wherever your system might be. So that's one possibility for your types of applications. That's a 4-way air handler that could be attached to that split unit. It can be upflow, downflow, horizontal, left or right. Again, not unique to my brand, but something we do quite a bit in your part of the world. This would be kind of a schematic of how this might look with a horizontal air handler in an attic. I threw that in for you folks because every house I ever lived in Texas had something in the attic, usually laying on its side. There's all different kinds of ways to connect these to a loop. Now, for those of you that are really unfamiliar with geothermal heat pumps, the loop is basically the outdoor unit. The compressor is always in the indoor unit, but the loop is replaces the coil and the fan that usually sit outside your bedroom window in Texas and Oklahoma. So there's lots of different versions of this. Horizontal loop, you might have a little bit of a backyard, maybe an acre or so. You could run a backhoe through there, do a 2, 3, 4, 600-foot trench. In Texas, you'd want to be 6 feet deep or so, not just for frost, but for, to keep the soil moist enough so that it transfers heat, even in the heat of the summer and the cold of the winter. So that's kind of a typical picture of what a ditch would look like. You can see 2 pipes in this ditch. You can do 4. You can layer them vertically. You can put them horizontally side by side. All kinds of options for that type of loop. You can go vertical, which is something that happens a lot in Texas. That's a small tract rig. They make those that fit through an 8-foot backyard gate. You can drill through a sidewalk, a driveway, a front yard, a backyard, a side yard. You could do 3 300-foot holes a day with that rig. Actually, 3 500-foot holes a day with that rig. That would be enough for maybe a 6,000 square foot house. You could do 1 hole 300 feet deep. That might be enough for a 1,500 square foot house. Just some ballpark numbers there. We never use rules of thumb, but that's good to know what the ballpark expectation should be. Typically what you see over there in the left-hand picture, the pipe goes down in pairs. You have a supply and a return pipe, and they feed a manifold, usually outside the house, and then would penetrate into a crawl space or through the slab or the sidewall of the house to get to the heat pump. If you have a pond or a lake, a river you can access, even salt water, you can do different types of pond loops. Our factory has had one of these in place for the last 31 years, and it provides us 800 tons of heating and cooling in a 2-acre pond. You certainly don't need that much for a typical home or building, but that's for our whole factory and headquarters. This on the top is just plastic pipe in a slinky formation, and on the bottom, that's stainless steel plate heat exchangers about to be dropped to the bottom of a pond. And those, you can expect those to last 50 to 100 years typically. Again, the one that we have in Fort Wayne, Indiana, is a pond that gets freezes over in the winter and so on. It's a lively pond full of geese and ducks and fish and frogs after 30 years, and it works great. We haven't had to do any maintenance on those coils in the last 30 years. If you were dropping this in salt water, perhaps you might want to get a titanium version of this plate heat exchanger, but same expectation for a long life with minimum maintenance. Something we see more and more of, particularly in places like Texas and Oklahoma, are horizontal boring. They do it for fiber optics. They do it for natural gas pipelines all the time, all over the Southwest, really all over the United States. I've participated in one of these projects that looked a little bit like the bottom picture. We did 9 tons of capacity between donuts and dinner, and wrapped it up, got it manifolded and piped into the building in 1 day. So this is a very effective, very cost-effective way to do things. In parts of Missouri, contractors own these types of machines and are able to install ground source heat exchangers for about $1,000 a ton. So very cost-effective in those applications. Skipping now from kind of the equipment and the loop to the underlying technology. We did do a refrigerant transition. We're done. We finished up last year at the end of the year, and the entire industry, the geothermal industry, switched to R454B. I know some air source heat pumps are now, and air conditioners are R32. Not a big difference, still minimally flammable, not explosive, low GWP refrigerant. That's for those of you that are new, that's global warming potential. Less than a third of the previous R410A for global warming potential. In fact, it's even lower than R22 was back in the day. This is what our equipment looked like before the refrigerant transition, and this is what it looks like afterwards. That's a joke, by the way. I'm trying to be funny. Didn't really change. Interestingly, if you use less than 64 ounces of R454B in a packaged geothermal heat pump, you don't really have to do anything. You don't have to do any mitigation. And where we did have to do mitigation, it was not really expensive. It didn't drive up our costs significantly. And we feel that we're really well positioned for the time being going forward. However, if I'm a gambling man, I'm not taking 6-year, 7-year bets on R454 or 32. That type of refrigerant may change. Of course, you know, the administration in the United States has a way of flipping back and forth. Regardless, manufacturers of compressors and components may switch to lower GWP components, and we will follow as things unveil. I put this little chart up there because it's kind of fun. It shows you GWPs down the center and the name of the refrigerant on the left. As you go down that chart to lower and lower GWPs, something interesting happens. The refrigerants become more flammable and more toxic. So down at the bottom, you've got great refrigerants like isobutane and propane. However, they're extremely flammable, even explosive. And you've got ammonia, and then crazily enough, water and air, but not very good refrigerants. However, in that sweet zone down around propane, those are really good natural refrigerants, even CO2. The challenges are that the equipment becomes more expensive as you go down that chart. So we'll see how things unfold. I'll be long retired by then, but it should be interesting. It's the future is not static, that's for sure. Today, we like to say modulating everything, whether it's a 2-speed or a variable speed compressor. We don't even manufacture residential equipment in single speed configuration anymore. And along with that, we have variable speed water pumps, variable speed air fans, blower fans. We have zoning. Dehumidification coils are now a thing on residential ground sourced heat pumps. That's kind of fun. And I mentioned earlier the hot water generators / desuperheaters, kind of standard on almost everything we ship. Sorry that everything has so many different names, but desuperheaters and hot water generators are the same thing. The result of that, you can see that's right out of a brochure for one piece of equipment. That's a 3, 4, and a 5-ton system. You can see the EERs there and the both cooling and heating efficiencies. Don't ask me why, but we still do EER for cooling and COP for heating. In the future, maybe you'll see COP for heating and cooling. But for the time being, those are our numbers, and those are certified, guaranteed, and typically what you'll see with geothermal is both the full load and the part load. Meaning, like if it's a 2-step compressor, that would be low speed and high speed. Variable speed, it would be down around 30% up to 100%. And of course, as your capacity goes up, your efficiency goes down. Nothing new there, but still very strong. If you look sort of over to the right in the bottom, towards the bottom, you can see part load EERs as high as 56 and 55. With the full load is all the way down to 27. Kind of tuck those numbers in the back of your head, and we'll go from there. More technology, remote access. Again, we talked about this a year ago. That's continuing to evolve and grow. The numbers of those systems is really exploding. But we provide access to all of those different parameters, and we store that data for the contractor, for the homeowner, and for us. It helps us do things like remote troubleshooting. There are folks at our factory answering the phone from technicians in basements in Wisconsin and crawl spaces in Texas and wherever, asking, hey, I've got this fault code and can you help me? And our technicians at the factory will look at that and say, well, you've been bouncing off your high limit for 2 months. Did anybody ever check the filter on this thing? And most of the time, there's an embarrassed silence after that, and then a filter gets changed and everything's okay. But it's nice to be able to see all of these varieties, all this variety of data. We can tell if a coaxial heat exchanger is clogged, or it's been frozen, or if it's leaking, or if a compressor has got a high limit or a low limit cut out. We can pretty much tell everything. We can even tell when your filter needs changing from your fan watts and so on. So checking that data every 10 seconds gives us a real good picture of what's going on. That was a real breakthrough we made about 10 years ago, and those systems continue to deploy across the United States. Here's a better picture of it, and a kind of a funny, you can control a compressor cutout from a cruise in Croatia if you have Wi-Fi. We have added things like cell phone access to this program, cell phone troubleshooting, and you can even not just do the diagnostics, but actually affect repairs remotely using a cell phone anywhere in the world. That's kind of fun. How Geo happens in Texas, what you see is a whole bunch of folks in training classes, learning how this stuff works. And in the end, most of these folks will get up from their seats and say, that's actually easier than what I've been doing for the last 10 years. Because most of the equipment that folks work on is packaged. There's no refrigeration work to be done. There's no field charging or anything of that nature when you're installing a packaged ground source heat pump. It's just hooking up the water lines, low voltage, high voltage, and connecting the ductwork, and you're off and running typically. You can see on the bottom right, there's a live laboratory where you can work on equipment, and the same in the lower left. That's our residential hands-on lab. So whether you're doing a 600-ton chiller or a 2-ton water-to-air type system, we've got hands-on laboratories, and those are real popular with folks that are willing to travel. Or, as you can see in the middle, all us manufacturers provide on-site training in how to do this work. How does it happen in Texas? I mean, how does it go from 0 to 60? Where does it begin? There may be a homeowner on this call who's curious or saw a YouTube video or heard about it on the radio or watched something on TV. Well, whatever the case may be, they're probably going to call somebody and say, can you give me a quote? That's where it starts. It says lead factory up there in number 1. That's just something my company has is what we call a lead factory, where we process leads out to our participating dealers. And I guess the first step after that would be a savings calculator look, and then a site visit where you kind of got a feel for the existing house, or maybe even the house that's about to go in, and say, hey, if you could build it this way, it would be a little bit easier for me. Or if it's an existing home, you can say, well, that return's a little small for 5 tons. We're going to have to open that up. Or you got a leaking duct over the master bedroom, or, whatever the case is. You're going to want to look at all that stuff and double check the load, double check the equipment sizing, and then build a quote from that information. If you're a contractor, that's what you're going to use to do your loop design, which you're probably not going to believe this, but it really should take about 5 minutes once you've done it a few times. And all you have to input is pipe size, location, vertical, horizontal, things like that. And you're on your way. Loop design's pretty darn easy. The software is online. You can do it on tablet, laptop, and it's really not a problem. That will also give you a financial comparison of, say, 16 SEER, if that's an option, or you can compare that to a two-stage or a variable speed ground source heat pump. And then you can price it out pretty quickly online, whoever your supplier might be. And then you close the deal, hopefully for you, order the equipment, and schedule the loop installation. Some of you may have backhoes and do your own loops. Some of you may have a subcontractor. Some of you may use a driller. Some may use a trencher, a boring machine. It's up to you. In some cases in Oklahoma, your utility may do that for you. And as you're doing all that, keep in the back of your mind, there is a 30% federal tax credit on all this equipment, whether it's residential or commercial. Commercial can go all the way to 50% in some cases on the tax credit. And you don't have to pay taxes to get that credit, meaning churches, schools, universities, cities, towns can install this equipment and get a tax credit paid to them. So it's kind of a nice deal. If the University of Texas puts in a $10 million geothermal system, which may or may not happen, they would get a $3 million tax credit on that, significantly lowering their capital investment. Or if you're a homeowner doing a $60,000 install, for instance, maybe, a big 5-ton unit, that's an $18,000 tax credit to the homeowner, bringing the cost of the install from 60 down to 42. Kind of nice, kind of a nice feature. And that's still alive and well. That hasn't been changed. I mentioned a savings calculator. All suppliers in the industry do this. This is the WaterFurnace version. I just picked a house, place I actually used to live in Texas. And that's what my savings calculator would look like month by month. And from my memory, those numbers just about right as far as the before is concerned. And I did this last year with this same house, but I updated the information. We're zooming in here. Anybody know where we are? Yep, we're in Plano, Texas. Right here, this is 2300 Evergreen Drive in Plano, same old place. And that's the front view, kind of a typical 3-bedroom, 2-bath kind of house, rear garage. Here's what they would save in Plano, Texas, $2,500 a year. And you can see the breakdown: hot water, heating, cooling, electrical, what the total makeup is before and after. That's pretty fun. Your homeowner and you can look at that, or whoever the customer is can look at that at their kitchen table and make their own decision. When you think about, I mentioned $60,000 going to 42, over 10 years, you're going to save $25,000 on your utility bills. That's a pretty reasonable cost over a 10-year period. The nice thing is, after 10 years, you don't have to buy another one. Your loop still has over 100 years left, and your equipment should have over 20 years left as far as life cycle goes. So as we like to say, after 10 years, we're just getting started. So that's some savings that you could expect. And this is something else you can expect. This is a common response. I don't believe that. Well, I mentioned a little while ago that 10 years ago, we created this Symphony controls. And one of the things it's done for us is we can track energy usage and all over the United States. There are over 20,000 units connected to Symphony right now. We display about 15,000 across the US. We've disconnected some of the hydronic units. But in any case, that's Texas right there. There's 272 systems on a on the map, and this is their typical usage. In Vidor, Texas, these folks have a 6-ton residential 2-stage compressor unit that's water source and forced air connected to their ductwork. You can see, as you would expect, their heating is only 1/10 of their cooling. So it's about a 10 or 11 to 1 ratio in terms of energy usage. And over the course of the year, they used about 5.5 megawatt hours, or 5,489 kilowatt hours. And that costs $686 at 12.5 cents a kilowatt hour. So that works out to about $2 a day for a 6-ton system right there, not too far from Houston, Texas. And we can highlight every dot on that map and see exactly what that situation is. Just sort of to give you a feel for where that stacks up, that's a little bit higher than normal. The Texas average as of today, over the last 12 months, 8,760 hours, people have spent on average $591 a piece to heat and cool their home and make hot water to dump into their water heater. How about that? I don't believe it. I still don't believe it. Well, this is kind of the underlying data. Every single ground source heat pump manufactured and sold in the United States is listed on the HRI directory. This is very important. The Department of Energy audits 10% of these every year, and violating your certified ratings is punishable as a felony. And we take it very seriously, as does everybody else in the HVAC industry. Anybody who manufactures any kind of heating and cooling equipment pays a lot of attention to this. In the blue arrow there, you can see that's where all the ground source heat pumps lie on the chart. I don't think any of our competitors, and I know that we don't manufacture anything below 17 EER for any residential applications, period. What you see in that bell curve to the left is in orange is all of the air source heat pumps listed in HRI directory, their EER, and the 5 tons down there at the bottom. So you see a center point around 12, a couple of units up to 13 and even 14, but 0 units above 15 on air source products, regardless of who makes them. And I did that for many years. I built air source heat pumps and rated them. And I hope there's questions at the end, because this is something I really know a lot about. So anyhow, that's the science behind the savings. This is maybe I kind of covered up the numbers because they're wild goose chase made up numbers. These are different choices that you might have a good, better, best option. The highest efficiency on the left and the lowest on the right. Maybe from a 50 EER system down to a 12 EER system on the right, which would be about a 16 SEER on the right. And there's a weird unit there, second on the right-hand side of the middle there with a big fan on it. We actually manufacture a hybrid heat pump that can be an air source heat pump or a ground source heat pump. So, maybe you want to install it today, but you can't get your loop installed for 6 months or 10 years, then you can operate off of a outdoor condensing fan temporarily or even permanently. So just different choices. There's lots of options for contractors, but this is what you might see at the kitchen table between a contractor, installer, and a homeowner. So I'm going to just wrap up with some fun stuff here. We're doing pretty well for time, but this might be interesting. This was me. I'm the skeptical man. Why would you want to electrify if the electricity is made out of coal? And in Texas, a good amount of electricity is actually made out of coal. Where I used to live in Texas, it was about 100% coal, at least for a while. I haven't been there in a while, though. Anyhow, does it make sense to switch from natural gas furnace and an air conditioner to an all-electric system? Yes and no. No, it doesn't make sense if you have a low efficiency electric heating system. And to be fair, over 60% of Texans heat their homes with resistance electric heat at a COP of 1. That doesn't make sense. But what does make sense is very high efficiency heating and cooling with electricity. Okay, this is the data right here. If you're heating your house with natural gas, you can go through this equation, and this is a 2.5 ton house, making about 5.5 metric tons of carbon dioxide every year. And if CO2 is your thing, if that's your concern, or if that's your measure of pollution, whatever you want to call it, if that's your global warming bugaboo, that's what a 2.5 ton house is going to give you for heating only, just heating only, in terms of CO2 output. If you flip that to an all-electric, high-efficiency geothermal heat pump, I said high efficiency, that's really kind of middle tier efficiency, geothermal heat pump, you go down to 1.1 metric tons. So exactly 1/5 as much CO2 emissions as a result of using the coal-produced electricity. So yes, it's not like a Tesla with a generator on the back. It actually makes sense. It's 1/5 the global warming potential, if you will, for heating. Here's a fun story. This may not be a big deal in Texas, or it may be. It's right now, it's kind of a northwest and northeastern thing, kind of an East Coast, West Coast thing, but also popular in places like Iowa and Colorado. Thermal energy networks. We call them TENS. Some folks call them geothermal districts, where you can connect different buildings. Imagine heating a neighborhood with the waste heat from a data center or an AI processing center, and maybe a hockey rink. They put out a lot of heat in the middle of winter. They could heat a lot of buildings, and then store the heat in the ground in the summertime. So lots of different ways to do this. Grocery stores are a classic way to heat and cool neighboring buildings. They work together and provide really good load balancing. So these are going in now. We just completed the first utility-owned version of this in Framingham, Massachusetts. They're all filled with WaterFurnace equipment. We have rooftop units, ductless consoles, forced air systems, hydronic systems, you name it. But it's a very diverse system with a fire station, low-income housing, and all kinds of different buildings on that network. And it's operating today and exceeding expectations. This is weird. It kind of caught me by surprise, but Texas is considering a bill, and you can see the status of it there. A coalition of folks are looking at this geothermal district team and trying to shepherd it through the Texas lawmaking process, allowing municipalities and other taxing entities to own districts that look like that. So theoretically, if this bill passes, the city of Dallas or Houston or San Antonio could create a geothermal district. San Antonio could use the river through the middle of town to transfer heat between buildings. You can do it with pipes, you can do it with surface water, all different kinds of ways to do it. Even wastewater and drinking water have been used in different types of networks. But this bill would allow cities and towns and counties and so on in Texas to own those systems and operate those systems, kind of removing a barrier letting them do that. I mentioned Iowa earlier. There is a city in Iowa that has been doing this for a number of years. They heat and cool everything from their sidewalks to their whole downtown district with geothermal heat pumps in a shared looping configuration. This should be a surprise to you. The gas companies are behind this. I say the gas companies that service more than half of the gas users in the United States have formed a coalition to figure out how to do this. Not because they're getting out of the gas business, but sometimes it's just cheaper to give people ambient water to cycle through a heat pump and get paid the same amount than it is to pump gas into that house. So if a gas company can see a way to do this and make money and actually relieve themselves of any risk associated with pumping high pressure gas, that's a good solution. So it's not just in Vermont or California. In fact, it's not in California, but in other places like Colorado and Texas, Pennsylvania. Very interesting. So even in fossil fuel producing states, this is an attractive option, thermal energy networks.
Well, I'm assuming that's also, I mean, a lot of the PUCs and utilities have carbon reduction goals that, you know, they can do 20% of their infrastructure with using this type technology, and that would help them reach their goals much faster.
100%.
Yeah.
Some of you may be familiar with the renewable portfolio standards. Various states have set goals for themselves to produce renewable energy. A couple of years ago, several states, including Maryland, looked at that and said, we can't make those goals. Why are we not including ground source heat pumps in this? As a result, homeowners in Maryland with existing ground source heat pumps are harvesting between $2,000 and $4,000 a piece in geothermal renewable energy credits, just like solar, just like wind, and they're getting those every year for 8 years. And it's not just new installations, it's folks that put them in as long as 5 years ago. So Virginia's passing that same legislation right now. We're working on the details, and that's another thing. So renewable energy credits and supporting renewable portfolio standards and decarbonizing it kind of meets all of those goals. Don't know if Texas will jump on board with that, but we'll have to see how things shake out with this legislative session moving into the next one. That's all the material I've got. Ready for Q&A if anybody has any. If anybody's still on out there, this is my buddy Brian Shaw, who is actually on the line, and he may be up in the chat answering questions. I don't know.
Yeah, he's been dropping some links in there, so thanks for Brian for doing that. Appreciate that.
Brian lives in Texas and breathes in Texas, and would be glad to help answer any of these questions either right now or a year from now. So
well, we'll just go through some real quick things. I don't see any questions in the chat or the Q&A as of right now, but I mean, fascinating technology. And you mentioned a few house bills in Texas. There is one, and you did mention a little bit earlier about most homeowners will do electric resistance heaters, but that's probably, if that bill passes, it'll outlaw electric resistance heat for a primary source of heating in Texas.
Wow.
So that's to me, that's a win with energy efficiency because like you said, the COP of 1 makes no sense at all. But that's going to bring people into air source heat pumps or geothermal heat pumps if you don't have gas available for your community.
That's great. Interesting.
Yeah. So we'll see how that shakes out for sure. I watched your stuff last time, and it still fascinated me with the technology that you guys have out there. And again, I still learned a lot today just by looking at what you actually still have available to use and the technology that's come out there. But yeah, I mean, geothermal has always just been fascinating with me about how that stuff works. And I know, I mean, to me, it's one of those things where it's like that. To me, that's kind of a luxury. My uncles had it for years. They installed it many, many years ago technology wasn't what it was today. It wasn't as smart. There's not any smart stuff attached to it really. But I do know the highest cost of actually installing this stuff is drilling the pipes and the well, for the tubes that go through there. My question too is, and again, this is elementary because I don't know, but when you look at, let's just say it's a vertical loop that goes down and comes back up, when that stuff is installed, I mean, it looks like they're putting pipes straight into the ground, but if you go 200, 300 feet down or whatever the distance is that you go, how do they connect the loop at the bottom? Is it you basically dig a trench and just drop a looped tube down in there?
Yeah, you would just drop what's called a U-bend. At the bottom of the pipe, there's a U-bend. So you drop your supply and return pipes down into the same hole, and the water just goes down and back up.
Got it. Okay, that makes sense.
So it's typically a hermetically sealed system, and the joints are fused plastic pipe that should last a couple hundred years. So there's no exchange with the groundwater. Typically, it's just hermetically sealed. The only thing exchanging in the ground is heat.
Nice. And being that they're hermetically sealed, there's not any maintenance that you have to do with the water that's inside it over a year or a couple of years, do you?
Yeah, some folks like to do annual checks and make sure there's no air in it. You can, have the line purged, you can filter it. Sometimes an installer will get some particulate in there and you'll want to clean that out. But a lot of folks leave them for years with no maintenance, probably like your in-laws, I think you mentioned. But never hurts to go back in a year or two and check and make sure that everything's clear, there's no air bubbles, and it's operating properly.
And the last question I have for that, the water that's in there, is it under a certain pressure? Is there a pressure gauge on the equipment that says, oh, I have a leak because the pressure's dropped? How would you
So
know?
some systems are pressurized, and you'll get an alert if there's a leak, typically. Many systems in Texas and Oklahoma are non-pressurized, and they just, operate at 1 atmosphere. So that, either way is fine. Both systems we sell equipment to pump either water as a pressurized system or unpressurized. It's a kind of a installer choice depending on what they're trying to achieve.
Okay, great. And then last question I have, I know normal heat pumps have a backup electric resistance heat strip. Do these or do they just not need them?
In Texas and Oklahoma, you don't necessarily have to have them. What I would say is you might want emergency heat in case your compressor breaks, but I would say that you don't really want to rely on auxiliary heat, like as a routine. Now, because your loop is going to be in Texas and Oklahoma, you'll probably size your loop based on your cooling load. So it'll meet all of your heating load without electric backup. And that's a requirement by some utilities. If utilities give incentives on these, particularly in Oklahoma, they'll say, we'll give you $10,000 to put this in additional incentives, but no backup heat, no auxiliary heat, because they don't want that peak load. So the answer is maybe. I wouldn't put it in at my house here in Arkansas.
Well, that's a great point because if you don't do it in Arkansas, I wouldn't need it here either. I get, and then last thing, I'm just thinking this off the top of my head. Most heat pumps have a reversing cycle because they have to defrost the coils. Does your equipment do that at all, or no?
Well, our equipment reverses because it both heats and cools, but a
Right.
geothermal unit never has a defrost cycle.
Never has. Okay. Very good.
Yep.
And Brian's put some more stuff in the chat as well. Auxiliary heat for our equipment is available, but not normally ordered with equipment in Texas, Oklahoma. That's a great point, Brian. Thank you.
There you go.
All right. Well, I appreciate it, Will. And as I said earlier, oh, wait, there's a question by Casey. Is there a temperature maximum at which you can run the heat or min for cool, i.e., 60, 70 degrees for cooling and heating with regular heat pumps?
You can get pretty darn cold. As if you're going to require 60-degree indoor temperatures, you're going to have to put in a little bit more underground loop to achieve that. You can design for that. As you design your loop, you just plug that number in, and the length of your pipe gets bigger. The length of the required heat exchanger gets bigger. But yeah, it's achievable. You can get 60-degree, and you can get very hot. You can have supply air temperatures over 100. But that's a function of course, airflow, coil size, loop size. So it can be designed that way. Sure.
Basically, he says, "Sorry, I meant was how hot outside before you can run the heat. I meant how hot outside can be before you can run the heat. I guess."
Oh, heating in the summertime is easy. I mean, they'll make as much heat as you want in the summertime. There's
So I guess
plenty of.
I guess what he's asking though is there a default switch or something that won't allow you to run heat if the outdoor temperature is like 60 or 70 degrees? It goes beyond that point from outside. Does it just no longer allow you to put it into heat mode?
No, you can heat in any weather
Okay.
at any temperature. That's not a problem. Um,
Okay.
Whatever you
And
want.
then
There's a question about efficiency there. The answer is
yeah,
yes.
yeah. So Paul asked, would you achieve higher efficiencies with vertical loop versus horizontal loop because of the delta T?
A really big, deep, multi-pipe horizontal loop is more efficient than a kind of an okay vertical loop. But a big vertical loop with 3 or 4 or 5 holes probably better than a 300 or 400 foot shallow horizontal loop. So it's really about how you scale it. Typically, verticals more, shall we say, resilient to changes. Like in a 10-year drought, a horizontal loop might suffer, uh, especially if it's shallow, but a vertical loop wouldn't be affected.
Great. And then Casey backs up his other questions he had. He said, as an inspector, we're not allowed to run heat pumps when the heat temps are above 70 degrees outside. So he was kind of checking to see if there was the same kind of a default ruling on geothermal heat pumps as well.
If I had a critical need, like for cooling, like a wine cellar, or somewhere that had to stay cool all the time, or if I was incubating livestock like alligators in Louisiana, geothermal is very common there because they need a very steady, reliable, unbroken source of heating. So it's even in fairly warm weather, we're heating the alligators in Louisiana. So
Wow.
it's a very good technology for that.
Wow. That's good to know. All right. Well, I don't see any other questions. Thanks for everybody being on here. Again, this is my contact information if you want to reach out to me. At the end, as you saw, we'll put Brian's up there. Be sure to reach out to Brian if you have any specific questions about their equipment or a general question about geothermal technology that's out there. So thanks to everybody for being here. I appreciate it. As I said earlier, if you've already taken advantage of the CEUs for this, you probably cannot get another 0.12 is what this is going to be worth. So apologize for that. Sometimes we do rerun the same thing or have the same guest on that has the same kind of information. I did do an update on it, so maybe they'll accept it as a second, but it's got the same CEU numbers, so probably not. So be sure and connect with us as well. This is our direct number here. We also have our website address. We're on Blue Sky now. We are still on YouTube and X as well. So we're also on LinkedIn for that. Be sure and connect with us on our socials. Thanks again for everyone being here. I don't have a announcement for the next webinar, but be sure and check out what's going to be on our newsletter coming up in the third week of this month. And then you guys will see some stuff being dropped for that. Thanks, Will, for putting some of those things in there about the refrigerant. I know there's been questions about trying to get some things done for webinars for more information on the new refrigerants. I appreciate that information. I'm still trying to find someone that can get more deep in the weeds and more technical about what's out there. So pay attention and look forward to that in the future. So thanks again, everybody. Thanks, Will. Thanks, Brian. I really appreciate you guys doing this. Thank you.
Taylor,
You guys have a great rest of the week, and we'll see you on the next one. Thank you.